This conference will now be recorded.
Thanks everyone for joining us. It's great to have you here. So we're trying to just get a discussion going in the office about who's interested in mass timber, who wants to learn more about it. And I think the idea of this group really is to try to make it more of a recurring group where these people can always come together, really talk about what are the challenges they're facing. And I think especially New England, it's a very new project type. And so for this first discussion group, I think it would be great. It was great that we have Mark Rivard here from WoodWorks, who he's sort of the New England rep, I guess, for WoodWorks in a way. And I think he'll be a good person to give us an intro into what it can be, and then we can bounce some questions off of. Yeah. Mark, you want to take it from here?
Yeah, sure. Share my screen. All right, can everyone see my screen okay?
Yeah.
Yep, okay, great. So this is kind of what I was gonna run through today. It's saying cross-laminated timber, and that's something everyone's architects and engineers are excited about. But I've also included in this presentation a number of other mass timber products, and we'll go through some comparisons as well. If there are any questions, definitely just stop me. We don't have to wait for the end. We can have this be an active discussion, conversation as we go. This is basically, if you're not familiar with WoodWorks, I've had a few interactions with you all in the past, but for those of you who I haven't, we are a free resource for you. We're funded by industry, and the items you're seeing on the left, those are kind of the highlights of what we typically assist with, but really, any challenge that you have, just give me a call or drop me an email. We're more than happy to help. We have a really good staff behind us here, and I do represent New England and also New York. These are our funders, so this is how we're really able to be free. The Softwood Lumber Board is our primary or our main funder. About 50% of our funding comes directly from them. The U.S., it's interesting enough, the U.S. Forest Service is one of our larger funders as well. They're similar to FII, who's a group up in Canada. The reason that they actually started funding us is to start using more timber, so products like mass timber that use more board feet. And the reason for that is global climate change, sequestering carbon, sustainability, and health of the forests and water is kind of their angle to it and why they fund us. If anyone needs AIA credit for this, I'm not quite sure how we'll do that. If you want to send me a list or individual emails with AIA numbers, I can have those processed. But I'll also send a certificate of completion for license reporting as well. So I don't know if you guys want to send a list or how we'll handle that. We can kind of discuss that after. And then just a couple of mandatory AIA slides that I'm going to fly through here. I'll also send a PDF of this presentation as well. So I know it's recorded, but if you want PDF slides, then you'd have them for the future. Learning objectives, again, this is just another mandatory AIA slide. It'll be on the recording and then the PDF as well. So I'm not going to read through all of this just due to time constraints that we might have. So let's jump into our quick outline here. What is cross-laminated timber? But first, backing up, what is mass timber? It's kind of a newer term, and really it's an industry term. So you won't find it in the building code until the 2021 IBC. It's similar to traditional heavy timber, except all it is it's smaller dimensional pieces of wood that are put together to form larger pieces. So what you're seeing here, two different types of mass timber. You've got glulams, and then also you have that floor decking is actually nail laminated timber. In the code, that's called mechanically laminated timber. That's been in the code for quite some time now. It's been used for about 100 years. Looking at some of the appeal to mass timber, the primary one far and away that I do see out of all of these is really innovation and aesthetics. So most architects come to me. The reason why they want to do it is to expose the wood, whether it be an office space, which is really common. A lot of university spaces are looking into it, things like that. But that really is the biggest driver. Construction speed is something that's often overlooked. You save about 25% on your construction time. It's really becoming more popular in an urban setting. So there's a few now in downtown Boston, smaller applications, not very large projects yet. New York City, This is about to be put in the code in New York City if you do any work there at some point this year. Of course, the current situation may have delayed their code cycle. But in New York City, for example, and I'm hoping this is true in Boston because of high labor costs, there's only 4 projects that have gone forward until the New York City, the fire department and the building department put a stop to it because it wasn't specifically in their code. We're talking about CLT here. Those 4 that went forward actually came in below a steel frame project, and it's because of high labor costs and construction speed. That's not the normal. So I kind of tell everyone it's ironic that New York City comes in lower consistently and you can't use it. Not yet anyways. So hopefully that also translates once we see a few projects, mass timber ones in Boston as well. Some of the secondary drivers, it's lightweight. So if you compare it to a concrete building, for example, it's quite a bit lighter. We've seen firms, architects really take advantage of this when they're adding stories to an existing brick building. I'm helping with a couple in New Haven where they were able to get an additional story than they would have just due to the foundations that were beneath it, using mass timber as opposed to laying brick or masonry up and then going with the heavier concrete system. And then carbon reductions, that's a big one here in Massachusetts, also Boston as well. I've been working with the state. They're really starting to push more projects due to carbon reductions and sequestration of carbon in the buildings. The UMass Design building actually got a grant for this, which I'll show a little bit later on. And just to get that one over the top, that was years back when it was far less cost competitive. And then I just recently helped out the state of Massachusetts with the Department of Unemployment building that I believe is in Brockton. And that's a mass timber building. And it was because the state really was the driver. It's really popular with universities for that reason as well. So I did mention we'll look at a few of these other elements, mass timber elements that are available. So dowel laminated timber is one. It's really the same thing as nail laminated timber, except you're using wood dowels instead of nails. The advantage of the wood dowels is actually it's really for cutting. So if you have to cut the panel, you're not cutting through nails. It's an all wood system. That's why they basically went with dowel lam. There's one firm in Canada that does this. Out in the Pacific Northwest, they're creating mass plywood panels. Now, this isn't really going to be too popular if you're going to expose it because the exterior lamination it's plywood, which isn't always best to look at unless they add a veneer. But as we start to go taller, where you have to cover up the wood anyways, I think this might become more viable product, more practical. Some of the other ones that are available, glue lams used all the time in mass timber buildings, a little bit lesser, but again, as we start going taller, maybe LVLs, PSLs, LSLs, where you're going to cover it up might be something that can be used in tall wood buildings where it's not going to be exposed anyways. But we're really going to focus on cross-laminated timber, nail lam, and dowel lam, and glue lams today. Timber composite construction is great. It really stiffens up the floor system. The challenge with it is that it really adds quite a bit of cost to your project. So there really has to be a big driver to do a composite system where you're connecting the wood to the concrete. It's more commonly done that you actually separate the two. So what is cross-laminated timber? It's large wood panels, anywhere between 8 to as much as 64 feet wide. It's basically boards that are planed down to 1 3/8 inches generally, depending on the manufacturer. So they're nice and straight. They lay them down perpendicular on glue layers, and it forms these larger panels that are really similar to precast concrete, except it's a lot lighter and it looks a lot better, and it's more environmentally friendly. And here's a cross section of it. Usually when I do these things in person, I bring a CLT sample or an NLT sample, but this is basically looking at a cross section of it where it's odd number of layers. And then also they're oriented at 90 degrees to each other. It is finger jointed together. So really what that means is, in theory, these could be infinitely long. So really the only limit that you have is shipping. So what can fit in a container? Some of these products are shipped from Europe. So what can fit in a shipping container, or if it's more locally in the United States, North America, what can fit on a truck as you're trucking it either from the Pacific Northwest or from a plant down south from us, or Nordic is the one that is the closest to us, which is north of Montreal. Your different layups, as you kind of go through a design of a mass timber building, you really want to optimize it. You really want to stay away from 7 and 9 plies. They just I rarely see a 7-ply go forward. I've seen a 9-ply on one project only. Really for floors, you want to start with a 5-ply or even a 3-ply, depending on your fire rating requirements. So a 5-ply is almost always going to get you over an hour fire rating. 3-ply, we've seen that on projects where, it's 3B construction, where you don't have a fire rating requirement, or 5B construction. Or if it does require a fire rating, usually what has to happen is you have to shorten your spans a little bit, just to account for the char rate, which I'll get to in a second here, which is one of the big topics of exposed timber. This is how it comes together if you're going to use it as walls, although walls are rarely used. In CLT, usually it's a post and beam system due to cost concerns, but also the post and beam system is usually used because oftentimes the walls are covered up anyways. So if you're going to use all that wood and cover it up, it doesn't make a whole lot of sense. There are a few projects that do go forward and expose walls, but usually that is the driver. If you're going to expose the walls, you can use mass timber. If not, you use something else. So embodied carbon, as I said, that's a big one for state projects, university projects. In the Northeast, there's, I don't know, 15, maybe a little more projects that are looking at using mass timber for this reason. Some of them have already gone forward. We do have a carbon calculator on our website, so if you ever want to compare, what are the savings that you get from using even if it's light frame, but also mass timber, which sequesters more carbon, what's the comparison? And that's basically what this is, and we convert it so it's easy to understand to vehicle operation and home operation. Just because metric tons of carbon are just something that I can't even wrap my brain around. It's not something that I fully understand. So we've converted it. That's a free calculator on our website. I'm sure you've heard of this project here, but kind of a good story behind this one is this one was tasked with meeting the Living Building Challenge, which is far more accurate than LEED. And this initially was going to be a steel building, and in my opinion, it still looks like a steel building. So they were having a tough time meeting all the requirements. They called up my colleague up in the Pacific Northwest. This was years back, and he ran in there and gave them all the carbon metrics, some of the data behind it. And before you know it, they said, well, we're flipping this thing to wood. It's going to make it easier. And so even though it looks like steel, here's kind of the metrics of the building. Post and beam system, they actually used nail laminated timber. At the time this building went forward, cross laminated timber wasn't really used a whole lot in North America, so they used a different product, which they used nail lam for this one. And that's kind of the look that we see a lot of architects and owners going for. The owners are actually able to, in the end, it's not guaranteed, but they typically are able to sell or rent their units out at a faster rate, and also a little bit higher percentage as well, just because of the exposed look. There's very minimal waste, so these are very efficient. These panels are manufactured in the plant. There's going to just be a bunch of sawdust is really all you're going to get in the end. You can see you're able to cut openings for walls, or those could also be a floor opening for mechanical, things like that. The image down on the right is a project that went forward in the Pacific Northwest, and this was on site after they did an entire story. This was basically all the dust that they gathered, so that was the waste for an entire week of work that you could just pick up with your hand. Energy operation, so it's really highly energy efficient, particularly if you're going to be using mass timber, which is usually CLT, in an exterior envelope. The passive house designers are really interested in using CLT for their envelope because it gives you a little bit of a thermal property, so it's 1.25 value of R per inch. But more importantly, it gives you a really tight building envelope that you just couldn't get out of a wood building previously. So it is advantageous particularly for passive house designers. Disaster resilience. So this has been tested for seismic, although this is not a huge driver on the East Coast. Out west, it's far more important for seismic load. So this was a test that was done at UCSD in San Diego. And then if you do any government buildings, this has also been tested for blast. So this was kind of spearheaded from us as a request from the federal government, where they wanted to potentially use wood on projects that had blast resistance. I've done a ton of blast designs, not a ton, but a number of them out on the West Coast. That's where I primarily practiced. And the Navy was one of our clients, one of our big clients there. And we never used wood. It just wasn't even a possibility. It was typically concrete or masonry. I did one steel blast design, which was a nightmare. So any type of a post and beam system is a poor system for blast, because you pull a column out, you're going to get partial or full collapse. But anyhow, long story short, this was tested for blast. It's now being used on a few projects now on military bases that require blast testing or blast resistance design. This was the first one. This was done by Lend-Lease, and it's in Alabama, just a 4-story Candlewood Suites. Doesn't look like a timber building. It's all clad in brick. And there it is under construction. And kind of the shame of this building is even on the interior, it doesn't look like a wood building. They covered up 100% of the timber on this building. That I think it had more to do with legal issues and things like that, where all the Candlewood Suites have to look identical. So they covered everything up, unfortunately. I think they may have taken that one a little too far, but just some of the metrics, not that large of a building, 60,000 square feet or so. And this one, again, did use CLT in the exterior walls for that blast resistance. That was the whole purpose of it. Lend-Lease is now on their 3rd hotel. Fort Drum, I think there's going to be 2 of them, so a little bit closer to us. And jumping into fire resistance, this is typically the #1 topic for timber design, whether it's light framing or mass timber. There are 2 different ways that you can go about fire resistance with exposed wood or even wood that's encapsulated with gypboard. There are a ton of fire tests. So on the left there, that's just one of many. We have an inventory on our website. So if you want to go to our website, and it's under, I think, solution papers or something like that. It's like 4 tabs over. Click down, you'll find it, and there's a whole host of tests. Now that actually isn't a code requirement, that's just one way. So the IBC actually references the 2015 NDS. Currently, if you're in the 2015 IBC, that's the code path. And in chapter 16 of the NDS, that's the design specification for wood, so that's our wood code. Chapter 16 goes through how to achieve 2 hours, up to a 2-hour fire rating with exposed timber. And it's very easy to do. It's about, I don't know, 3 pages or so of code writing. And the general idea is we understand how timber performs in a fire. It chars at a very predictable rate. So understanding that, we know exactly how much we're going to lose during a really heavy, intense fire. As long as you have enough structure behind that, the char layer insulates the wood, then you're code compliant at that point. This is where it's in the code. This was for the first time here in 202, in the IBC. So beyond getting the fire ratings, this is actually one of the items that I typically help architects with, on mass timber anyways, more than anything for mass timber projects. How to classify your building if you're going to do mass timber. Most architects jump right to type 4 and they say, hey, I want to do a type 4 building. The drawback to that is you can't have any concealed spaces unless you're going to get a variance currently. That is changing, but currently if you do a type 4 and you're 100% code compliant, you couldn't have any concealed spaces. This is really kind of modeled on our mill buildings that we have here in New England. So brick exterior, interior is all heavy timber members. You do have the opportunity to use mass timber and heavy timber in types 4, in types 5 and types 3 construction. The advantage of both of these construction types is you can have concealed spaces in both of them. And just kind of looking at performance of wood, this is a Glulam E119 test. Both of these beams were unprotected, so there was no gypboard, there was no fire spray on. And you can see when this steel beam buckled, the Glulam actually had about 75% of its strength. So we understand that it performs well in a fire. This slide was a little out of place, probably should have been 2 up. This is the code path of the fire resistance that I mentioned before. TR10 is a document done by our partner organization, AWC, which goes through calculating the fire resistance. It's a little bit long of a document, but it's there. And now jumping back to construction types. So if you're going to do, we're a little out of place here, but if you're going to do a building in types 4, this is basically what it is. Exterior walls are all non-combustible. or you can use fire retardant treated wood. Now, cross-laminated timber does not currently come in fire retardant treated wood, but you are permitted to use it in the exterior walls if you add a layer of FRT plywood or a non-combustible layer to the exterior side. You can't have any concealed spaces on the interior, but the advantage of type 4 is the exterior walls where you can use CLT if you want to, but also the interior, you don't have to calculate fire ratings. You basically design structurally what you need, and then you basically just check a table in the IBC to make sure that you have minimum thicknesses, widths of members for floor beams, floors, roof beams, columns, and roof decking. And if you meet those or exceed those sizes, you've met to the code in terms of fire. So the code just kind of understands that heavy and mass timber performs well in a fire, and it's just looking at minimum sizes. Now, most timber structural engineers will actually, if it's type 4, they'll still go back and check that. It gives them an hour, but it's not required per code. It's just kind of the more experienced ones do just make sure they have that hour. This was the concealed spaces that I've been kind of harping on here, where you're not permitted to have it in type 4. And this is a huge one architecturally. You can't hide mechanical items, things like that, electrical, everything is 100% exposed, provided that they don't get a variance. So there are projects that did get a variance. UMass Design Building is one where they basically had concealed spaces just in locations. They did is they brought sprinklers in the concealed space. Now, technically, that's not in the prescriptive code, but they were able to get a variance for that one, and that's the way that they went. They could have classified their building as type 3. They just didn't come to me early. The whole problem would have went away. So what do we do if we don't want to do a type building? We want to have concealed spaces. So the easiest thing is if you can do it in types 5B or 3B construction, then you wouldn't have a fire rating requirement for roofs at all. You can have spacers, you're good to go. Now, what if construction types don't work due to number of stories or allowable area? You can also do it in types 3A or 5A with concealed spaces, and you simply just have to calculate the fire resistance that the timber provides, which is really easy to do, or show the testing that it meets and exceeds it. The only disadvantage of 3A type 4 construction is if you want to use CLT in the exterior walls. It is permitted in type 4. It is not permitted in 3 currently, which makes no sense in my mind, but that's what the code is. Types 5, you can use CLT anywhere or mass timber anywhere. So let's jump into the, so we have to typically look at acoustics a little bit differently for a mass timber building, because for the most part, we want to expose the undersides of the floors and the roofs. Now, if you don't expose the underside and you have the ability for a drop ceiling, acoustics becomes pretty easy. But 99% of the time, it's not covered up. So we usually have to do something else. As you can see here, the challenge for STC and ICC is really ICC. So your footfall is only getting you about halfway there from the bare panels. Now, we don't have access to the underside, so we have to do something up above. And this is kind of a common layup that we see, or an assembly that we see. The black element here, that's typically an Acoustimat. There's a few companies that make that. And then either an inch and a half or 2 inches of gypcrete topping or concrete topping, and then whatever flooring you have. And when you do all of that, you get an ICC above 50. Now, Acoustatech, the other one is Maxon. They both have some pretty good interactive tools on their website. So if you're looking at a mass timber building with acoustics, then definitely I recommend jumping on their sites. We also have an acoustical paper or inventory on our website as well. So the flexibility of this material, it really has given us just more options where we can use wood, which we typically wouldn't in the past. The project on the left is a project in Massachusetts that I assisted with, and this is a light frame building, and they just didn't want to wait for the masons to put up the shafts. They wanted to get moving quickly. They heard about cross-laminated timber, called me. I gave them the fire data that I just showed you guys and a little bit more. Before you know it, they went with the CLT shafts. They got these both up. This is a contractor who had never touched the material before. Now, they probably have touched cast concrete panels. But they got these two shafts up in about 4 hours, and the next day they run out of light framing, as opposed to course per course for masonry, which is you have to wait for it to cure, all that fun stuff. You do get flat plated systems if you want them. That's the two middle images, the bottom and then the top middle that you're seeing. That's more uncommon to do it, but it is possible. On the right, this is the timber composites that I was talking about before, where you're connecting the concrete topping to the wood, so it acts similar to a steel beam with the studs that are connecting metal deck and concrete topping. It really stiffens it up. But this is a project at the University of British Columbia, kind of their signature piece of the building. And they didn't drop columns in here. These are cantilevered, fully cantilevered steel, or wood and concrete composite stairs. So structural flexibility, it is quite a bit lighter. So if you're comparing it to a concrete building, it is significantly lighter. So concrete reinforced is about 150 pounds per cubic foot. Wood is about 35 pounds per cubic foot. So it is quite a bit lighter. Because it is, if you're comparing it to like a precast that you're seeing down on the left, if it was precast concrete, it's a lot easier to work with. Your crane size is going to be smaller. Your crew size is going to be smaller. It's a safer job site because it is that much lighter. And then some things that oftentimes I didn't even think about myself is it really is a silent job site. As you walk by these, I've been a number of them now. The only thing you hear usually is a drill, and that's pretty much it. It's honestly like a ghost construction site compared to what we're used to do. And because the crews are so small, there isn't a whole lot of yelling, which is common as well. Reduced construction time. Generally, you're going to get about a 25% reduction, as much as 30, depending on building size, in your construction time, and that's the erection of the structure. This particular project in the bottom left, the one up top is from Europe, so I'll kind of focus on the one from the United States. This was the first elementary school that used mass timber in the United States, and it took them, after they were out of the ground, 8 weeks to construct, and that was again with a contractor framer that had no experience with cross-laminated timber. Really, anyone who's done precast can do cross-laminated timber. It's the same thing. And there's just a shot of it. You can see it. Again, it doesn't look like a wood building. It's clad in brick. That's because they use a lot of brick for their schools down there. And then on the interior, you can see it's all mass timber. So they did use it for the walls for this project as well. There's their gymnasium. They exposed some of it. They have their Acoustamats there in the gym. And if they, the other thing is visually, I mean, you kind of have to cover up some of the wood here. If you didn't, it would look like a barn or a ski lodge or something like that. It is prefabricated, very precise. This is an image I've already shown, but you're going to be getting, once you select a manufacturer, you're going to send them a set of plans. So similar to steel, you're going to be getting a set of shop drawings. They help you a little bit with layout of the panels. They can sometimes do it a little bit more efficiently. So there is going to be that whole shop drawing phase. And what we typically hear currently, it's about a 10 to 16 week from the time they receive plans to the time when you can get panels delivered to the site. So you want to take into account a few months for that that whole process. If you use Glulam, you get quite a bit. Looking at kind of the timeline, so it did start over 20 years ago or so, a little bit more than that actually, and then sometime in the mid to late 2000s, the interest in North America began. Canada kind of jumped ahead by a few years, and they got their handbook done in 2013. We were a couple of years behind, but pretty quickly we got it into the. When I say we, I had no part of it. The AWC got this into the 2015 IBC, which was pretty impressive. It's really getting a new material in a code with that amount of speed is really tough to do. And the reason they were able to do it, and the reason why there are so many fire tests, is that very reason, to get it in the code. So nothing has really been tested more for fire, to my knowledge, than cross-laminated timber. There's just so many tests of it. So is it readily available? It definitely is. So Nordic up north of Montreal, it's in Chibougamau. They have a whole forest there that they source sustainably. They're the closest one to us. These were the first 4 North American manufacturers. D.R. Johnson's in Oregon. They use only wood. Lamb is in Montana. and they use a multiple species. Structural lamb, which is in Vancouver, also multiple species. There have been a few that have expansions. Two more that just jumped on the map here, Guardian and Element 5. They're producing CLT more for crane mats, so not for buildings. Of course, in a building are not certified for building use. That would be an alternate methods, which most folks don't want to go down. And then looking at International Beam, so down in Alabama, that plant actually just recently got bought out by SmartLam, so that's actually SmartLam and not International Beam. This is a little bit older over the slide. So they're up and running. They use southern yellow pine down there, which is a very strong wood. It's comparable to Douglas fir and also black spruce, which is what Nordic uses. Who else is on here? Katerra is another one here. They opened up in Spokane, Washington. And even since then, things changed so quickly. Vegan is another one in Washington who also is certified as well. So they're starting to pop up more and more. The one in Maine, we're kind of on that was gonna, there's another firm that came to, they never really, basically internet down in Alabama. They put all their there and they kind of abandoned Maine for now, and they actually a little bit later on. So Joel, see here in New England, but hopefully we'll get one here soon. So just looking at some project examples that we have here, you can do it a post and beam system. You can do a hybrid light framed where you're covering up the light framing and bringing in CLT floor and roof plates, or the full mass timber building that we've seen. The post and beam is far and away the most common that we've seen. I think it has mostly due to economics and also showing the wood off from the exterior street level as well. This was a little small project here that really was going to be masonry, and they switched it to CLT just to really save on really poor foundations. This was the one that also had the thermal test that I showed a little bit earlier in the presentation. This was the first one that used North American cross-laminated timber, and they did it in the roof only. So it's a post and beam system, very common, and they did it only for the roof plates. Has a really nice look to it. That was during construction. This is just kind of showing one of these large panels, how efficient it is. You're dropping it down. Then someone will come back basically with a gun, screw the screws right into the glue lens, and just move on to the next panel. So it is really efficient, easy to work with, and very quick. And then kind of the final product here. This is the project that I showed earlier. They went with a double layer, so they put them both in the strong axis in opposite directions because they didn't want to have any beams, and so it's a flat roof plate in Chicago. This was a design competition, which I don't know a whole lot about, but the goal was to do a flat wood plated system, and this was Thornton Tomasetti's design that they came up with, and they won it. So there's the two layers of 3-ply, so they're screwed together. Their columns actually go up through, and it's connected to that upper layer, and there's a plate you're not seeing here that's screwing them all together. But it does look nice at night. I did mention education is definitely a big one, particularly at the universities. This is a project in Oregon, and not that large of a building, 60,000 square feet or so. Classes, offices, meeting rooms, things like that. Very popular on the Pacific Northwest to use mass timber as the cost estimate. And this project this is an older slide. It was actually already completed. This was one that was done by D.R. Johnson. So you can see those are Doug fir glue lambs, and also the panels were also Doug fir as well. I'm seeing a bit of interest as well lately in office medical buildings, just more for kind of biophilia for the exposed environment, exposed structure. This is one that went forward in Washington, and I believe for the roof floor elements only. 3-story medical office building. This is a code in table 601. If you want to do timber in a roof only, there are opportunities for it. So in types 1B construction or types 2 construction, you can use a heavy timber roof or a mass timber roof. So it's just minimum sizes. So you size it structurally, make sure you're meeting those minimum sizes. As long as the roof has an hour fire rating or less, you can use it in a type 1B and types 2 building. The one on the right, you're seeing it where they did this as a project down south, and they just did it for the roof only. Everything else in the building is all non-combustible except for that roof. Then they exposed it. A little bit closer to us here, this is the Jetport in Portland, Maine. And similarly, this is a type 1B unlimited area building. So it's all conventionally non-combustible. They utilized that footnote, and they used all heavy mass timber for elements. This particular project used glue, and then they actually used decking on the project. This went forward in 2012 when cross-laminated timber really wasn't available, or they absolutely would have used CLT for this project. DeStefano and Chamberlain has said that to us many times, that if CLT was available, it was a no-brainer, because they basically had to put every one of these pieces in one by one on the roof, which is pretty tedious as opposed to dropping a prefab panel down and moving on. If you ever get a chance to visit this this airport, I did once, just be careful about taking photos. You get TSA swarms on you pretty quickly when you do that. UMass Design Building, if you ever want to visit this building, of course, the current situation is possible, but I can typically set up a tour of this building if it's critical for a project or for a client who just wants to see it. I know the professors there really well. This was, again, initially going to be a steel building. The professors were really the driver, because this is a wood science building along with landscape architecture. The professors really wanted this to be wood because that's what they do. And so they to do that, along with, they got a little bit of a grant for this one, but it's 90,000 or so square foot facility. It's a mixed use building, classrooms, labs, meeting spaces. There's a cafe. There's a wood testing lab, so they test some of the Western wood samples that might be able to use in the future for CLT. It has a really nice look to it. This one also does have the timber composite floors. So this floor here, for example, has a layer of concrete. It's connected down to the wood, and it's a really stiff floor. When you walk across it, you can't even tell. You can't feel any deflection at all. It was completed in 2017. This is kind of their entryway. Has kind of nice look with these zipper trusses. I had never heard the term before I visited this project. And they also wanted to expand where you could use wood even to their lateral system. So this is a timber brace frame. This is not very common. It's actually not in the code for seismic. So this was something else that they probably should have had an alternate design, but they weren't required to. The only thing that folks were concerned about this building for, because it was pretty new in the region, was fire design. That was the big thing, where they wanted just a lot of data on it. So I did help the engineers on this project. More commonly or conventionally used, this is the T3 building in Minneapolis. Developer for this one. They've now another one that's even larger in Atlanta. But anyways, this is a good one to kind of highlight the differences between cross-laminated and nail laminated timber. This is a nail laminated timber floor system. And if you look closely, these back joints that you're seeing, those were intentionally put in there for the construction phase only. The reason is as wood takes on and releases moisture, it expands a little bit or contracts a little bit, depending on if it's taking moisture or releasing it. Typically, that's not an issue in an enclosed building, but when you're in an exposed environment, if it takes on moisture, it's going to expand. Now, wood expands along the depth and the width only. It doesn't along the length. That's why you only see the joints on the sides of the panels. So that just allows these panels to move a little bit if it takes on moisture. Now, at the building, you can basically fill that in, or the enclosures in there, gear up your PC systems, fill it in with another 2x, or we've seen that filled in with mineral wool. They actually, for this project, they just left it there. They didn't actually fill it in with anything. The advantage of NLT over CLT is that it actually, because it's all in one way, it actually spans further than CLT. Well, where CLT is on its weak axis and it's oriented 90 degrees to each other, so it has laminations in both directions. So it doesn't span quite as far as NLT. The advantage of CLT over NLT is because it is cross-laminated, meaning laminations in both directions, As it takes on moisture, the lamination in the other direction does not allow the panels to expand or contract. So it stays dimensionally stable during the construction phase, where you don't have to worry about having these joints. So that's really the biggest design difference when you think about these two products. And there it is under construction. Their lateral system, they dragged all of their lateral loads into the concrete core. Just a rendition of it. They won't allow us to have photos. Heinz is pretty tight-lipped about their projects. This was one of the projects that I mentioned before, and this is in Brooklyn, and it was the first timber building in probably about 100 years or so. And this is on Wythe Street. It's two different buildings, a 3-story, a 5-story building, and it's a post and beam glulam system. Now, in New York City, you can't have any combustible exterior walls. So they intentionally had the exterior brick, and all the interior is post and beam. Brick is outboard of the structure, and it just basically grabs on at the floors. The interior, the floors, this one actually went with nail laminated timber. The reason is I actually directed them to do that. This was about the time when a couple of other cross-laminated timber projects that went forward were getting shut down because CLT wasn't specifically in the New York City's current building code, which doesn't make any sense, but they basically were shutting those down. So I said, well, you just to be on the safe side, you better use NLT. Now those other projects have now, their stop work order has been finally lifted after a long process, but this project started, gosh, 6, 7, 8 months after the first few that CLT ones I helped with, and it finished far before the other ones just due to the New York specific issues that they were having there. That's only a New York City issue. Outside of it, that's not the case. I was able to visit this building. I'll have to upload images in the future. They have office spaces on the larger building on the lower floor. Looks really nice as you walk in. In fact, I brought some potential folks who are going to use CLT from the Boston area there, and their jaws drop when they walk through this room. It's really impressive. Up above, it's all residential. It's offices on the lower space only. So jumping into the code status. So the US currently, the 2015 IBC and the 2018, which Massachusetts thankfully is not going to be adopting, is based on an Old Heights and Areas Act. It's really based on light framing. It's not based on fire protection systems we have today, design, fire engineering that we have that wasn't available at the time. It's really meant for light frame buildings that were not designed for fire, as well as you can do today. And because of that, you're limited to 6 stories or 85 feet. We know we can go taller with mass timber than that. It's already being done throughout the world, and also a few in the US as well. So it's nothing new. We used to do this before steel kind of dominated wood. Wood used to be our #1 material. Steel came along, and that became kind of the choice. And so what did we do? We weren't involved in this effort. Our partner organization, AWC, was, along with fire engineers, architects, code officials, fire officials. And it was a committee that it took about a 2-year time frame to say, well, we understand it can be used in tall wood applications. What are we going to do to get it into the building code? And so they did 5 fire tests. And we have a whole presentation on the fire tests and the new construction types that are going to be available. And I'll run through them quickly here. One was, and it was based on type 4A, which is going to allow 18 stories and 270 feet, fully encapsulated with, I think two layers of gypboard on all of the timber. And it actually had no sprinkler activation. And the fire test, the intent was to show that the structure with fire protection can withstand a really intense fire. It was like a 99 percentile. Let the contents burn out and let the structure still be standing. And it performed as predicted. And because of that, that's going to be available to you in the future. 2 tests were done on a maximum 12-story building. One of them was, again, contents burnout, and this was partially encapsulated, so exposing just percentage of the wood. And again, it performed as predicted. And once the contents burn out, no sprinklers, it basically passed the test. And then they also simulated a test where it was a 23-minute delay. And basically once the sprinklers were off, the fire went out completely. So it performed as predicted. They did the same thing with 2 more tests, similar to what they did for 4B, with the intent of a 9-story building up to 85 feet. So that really is 8 stories, which doesn't make a lot of sense to me. You can't really fit those stories in there. So they again allowed contents to burn out, and then they also allowed the sprinklers to be delayed by 23 minutes, perform really well. So these are going to be new construction types that are available to you. Types 4A, 4B, 4C, and then 4HT is identical to what we have today in the 2021 IBC, with the advantage of it is going to allow concealed spaces finally. So that was something I've been pushing for years, because architects tell me all the time that's a deal breaker to not be permitted to have concealed spaces. So that's finally been put in the type 4 HT construction in the 2021 IBC. So we do have some tall wood modern buildings here. This one's in Portland that went forward before these code changes. This was done in 2017, fully exposed wood. The way that they protected this building is they concealed their connections. That's usually the biggest design challenge for a timber engineer, is your connections doesn't need to have a fire rating. If it does, how are we going to do it? So concealing it is the most common way to do it. So the wood is actually protecting your steel connections. Brock Commons, so this is an 18-story timber building, and that's fully encapsulated. They used 3 layers of gypboard. Per design, they only needed 2, but they added a 3rd layer just as an olive branch to the fire officials in that area. This is in British Columbia. This is a student residence hall, and the speed of construction with this one was pretty amazing. So, June 6th to August 10th, so just a couple of months after they had this podium up, they had all of the timber up, in a couple of months. It went up actually so quickly, the next trade was incorrectly scheduled out weeks, beyond it. So this building just sat dormant, waiting for the next trades to get in. So it does go up really quickly. Looking at all the mass timber projects that we are currently helping with or that have gone forward, Pacific Northwest is far and away has the most. Kind of the next area that we see as has the most interest really is the Northeast. So this is something that's definitely up and coming. And just kind of looking at, we have someone like me all in every major area of the country. The Northeast gets by far the second most inquiries into mass timber projects from architects and engineers, building owners. That's an older slide here. We do have, before I take any questions, feel free to reach out to me, of course, but we do have an event coming up on June 3rd. It actually has 2 tracks. One of them is a mass timber track that we think is going to go really well. The other is light framing. And you guys are obviously more than welcome to join us. It's obviously a virtual event. We'd like to do our events in person, but the current situation, we weren't allowed to do it. But yeah, if you want to jump on our website, you need CEUs, or if there's a certain topic you want to listen to, feel free to join us. But if you have any questions, I'll take them.
Awesome, thanks, Mark.
Yep.
Any questions from the crowd?
I'll put one out there.
Go ahead.
As a firm, one of the things we like to keep in mind is the sustainability of the origin of the wood. How do different firms that are already into mass timber deal with that, knowing or not knowing where the wood is coming from? Or do some firms require it to be FSC certified? Just if you could just sort of give a general touch upon that.
Yes, so locally, most of the projects use Nordic, which is north of Montreal. They have their whole forest right there at their plant, and you actually know exactly, even like they can give you the exact location where all of your trees are actually sourced in your building. So not only would you know it came from that forest, they even can give you a location of it. They are FSC, FCI certified. They can send you green information. The second public school project to go forward was in New Haven, Connecticut. It was kind of a race. It almost beat that one in West Virginia. They actually like it because they actually show their students, they pull out a map and they say, this is exactly where our trees came from. Here's the forest, here's where they did the clear cut, and this is the right area where it came from. So unlike steel, concrete, where there's no way you can figure out where that came from, it actually is quite a bit easier to do with wood. I have never heard that story with some of the other CLT manufacturers. I imagine you would get something similar from SmartLam. They're going to use Southern Pine down south in Alabama. But similarly, the other manufacturers, they all have their own forests, and obviously they're doing it sustainably because they want to keep producing, more wood and make more money. If they kill the forests, they'll also kill their business.
So what percentage of projects do you see where the composite floor slab is used versus not used? You said it was more expensive and heavier to use the concrete composite, but it seems in a lot of the slides you showed, the concrete's there, it's polished, it's finished. Personally, I think it looks nice. Is there kind of a tipping point where it is just not ignored per se, but you leave the wood and don't add the concrete?
The concrete usually is going to be there for acoustics. So you need something heavy to take care of the ICC. So you're going to have, there are systems where you don't have concrete. There's a bubble mat or something, I forget exactly what it's called. I haven't seen that used on a project just due to cost. It comes in a lot higher than just pouring, 1.5 inches or 2 inches of concrete topping. So the concrete is typically there. As far as the percentage that uses the composite, it's probably less than 1%. The only ones that I'm really aware of are the UMass Design building, and that was really driven by the professors there to do composites. And the project that I showed with the stairs, there's a few more, but really it's a low percentage just due to the cost and labor increase.
So I'm curious, what do you think is next on the horizon for code? I mean, I remember sort of all last decade was there was a lot of looking forward toward the 2020 IBC and then what's going to happen next. And now that we've sort of adopted it, and I guess Massachusetts, we're looking at like 2021 to really adopt it. What do you think is next? What do you think are the next like barriers, frontiers for mass timber to break through?
Well, one of the biggest barriers is the sweet spot that we see this being used in a tall wood application anyways, is type 4B. So you're looking at 9 to 12 stories. What the folks that are trying to I'm helping with a few projects that they're trying to go forward under that construction type is, it actually requires you to cover up a lot of the wood more than they would want. I think you can only expose 30% of the ceilings or up to 40% of the wood, and it's an interaction equation if you're going to expose both. So usually they just expose the underside of your ceilings, of your floor and your roof deck. But 30% isn't a whole lot. So that right there is the biggest barrier that I'm seeing. So a lot of these folks are actually considering doing an alternate means and methods design within that construction type to expose more timber. And to do that, unfortunately, you do need to hire a fire engineer. So that's a challenge that I'm definitely seeing. As far as beyond that, it's just innovation and new products, I think is the next thing. Is what's next? I wish I knew.
Have you seen many projects using dowel laminated timber? Has that been common recently?
I have. It's people use CLT more, but the T3 building that's down in Atlanta used dowel lam as opposed to nail laminated timber. There's another project at a local university here. I forget which one. Anyways, there's a local university that's using dowel lam as well.
And why would they pick that over CLT versus NLT or anything like that?
I think it was the look. They liked the look of it. It looks a little bit different than, because you have a lamination at 1.5 inches as opposed to flat. It just has more of a razor look to it.
Mark, this is John Martin. I joined you late, so you may have said this already. Is there a kind of rule of thumb that you use to size the structural grids for these buildings? They all look to have about the same spans, and I'm wondering if there's a kind of a sweet spot for this mass timber.
Yeah, most people start with a 30 by 30, which is not optimal for a timber grid. So if you can do a 20 by 20 or a 20 by 25 or even a 20 by 30, something below 30 is usually what you want. The other thing is, as you're laying your grid out, understanding what your panel size is can be a little bit of a challenge, because each of these manufacturers, they manufacture different lengths. So once you have kind of narrowed down your manufacturer, you want to lay out your grid and your beams kind of spaced so that you're using the whole panel, because if you don't do that, you're going to end up cutting panels and throwing that away, and you don't get credit for panels that you don't use. You're buying the whole thing. So laying it out is actually a critical process, and in terms of cost and being cost effective. But the grid does want to typically be lower than 30/30.
Thank you.
Okay.
All right, anybody else? We're about an hour, but I've also recorded this, so I'll try to make this available later. But Mark, thanks for coming in. I think it was a great session. And I mean, you sent your email, so I mean, yeah, if anyone needs to reach out to you, they can do that. And I'm sure there's going to be a lot more questions coming along. So
Yeah,
thank
and
you.
as far as I guess the only challenge being remotely here is as far as license credit, so certificate, and anyone who wants AIA, how do we want to handle that?
Oh yeah, maybe I can assemble that. I'll send an email to all the people that attended, and they can just email me, and I'll put it in one big list. So you can just have one email that has all the AA numbers.
Okay, perfect.
So yeah, anybody else, anybody with an AA number that wants to get credit, send me your AA number, and I'll compile it. Thank you.
Thanks so much for organizing. That was awesome.
Thank you very much.
Thanks, guys.
Thank
Have a
you.
good.
Thank you.
Thank you.